At the lunar South Pole, there's a lot of permanently shadowed regions, PSRs. At the bottom of these PSRs are potentially a lot of ice and other resources. So being able to hoist solar panels well above these crater walls will allow astronauts and other assets on the lunar surface to get almost perpetual energy through the sun. The technology we're currently developing is called Diablo. This device here is the entire Diablo mechanism. One that would actually fly to the surface of the moon would probably be 30 to 50 meters tall. The top, this is where the payload would be. The center here is already a partially deployed boom, and the bottom is the rotary mechanism for deploying the Diablo boom itself. And if I rotate it this way, you can see the mechanism starts to grow taller. The shaft is a hollow tube, and it's kind of like a cylindrical zipper in how it unites. Here you can see the band lines, and you see the rivets connecting the bands. At the base of the mechanism, it rotates and engages these rivets with those bands. And by the end of it, you can have a pretty rigid tube structure. One of the mass advantages of Diablo is that the main structural component is a thin piece of spring steel. So this makes the structure very strong and relatively light for something that can deploy as tall as this structure can. Anything you bring to the lunar surface is very expensive. It's very expensive to launch a rocket. It's very expensive to land on the lunar surface. It's some of the most expensive real estate to bring something to in our planetary system. Anything you bring there, you want to make sure it's very efficient, very lightweight, very volume optimized, and potentially reusable. Diablo is a very compact system. It's a deployable boom in a very small mass and volume package. Again, you could imagine putting solar panels at the top of the Diablo boom, or for directing light at different parts of the lunar surface, or for providing laser communication to different regions on the lunar surface. So the next steps in our development of the Diablo system is to scale up this prototype into a large system. We've already scaled one up to about 30 feet tall. Next step after we test that system, then we're going to deploy it in a very large thermal vacuum chamber, run a deployment up, run a deployment down, validate that we can use this system in temperatures and vacuum pressures similar to the lunar surface. We're currently in about the end of the first year of 3 years of funding for developing this system. At the end of this period, we hope to get further funding to develop a system that could actually land on the moon.